I am Anil Kumar. Welcome to my series on quadratic relations. We are discussing factoring. Here is a test paper on factoring techniques. We have 8 questions in this particular test paper. I'd like you to go through these questions along with me, solve them, and then look into my solutions. Here is question number 1, which is to determine greatest common factor in the following expressions. So we'll begin with the greatest common factor, and then we'll take up questions based on factor fully, use most appropriate method. So 4 questions here to factor fully. You have to use the correct method, the most appropriate one. Now these 4 are followed by 2 more. Factor fully, use most appropriate method. You can note these questions, try them out. And then we have question number 4, which is determine the value of k in 4x squared plus 12x plus k, where that will create a perfect square trinomial. Question number 5 is the area of a rectangle is given by the relation a equals to y squared minus 11y plus 28. Provide an algebraic expression for the length and width of the rectangle. B part is if y represented 10 centimeters, determine the area of the rectangle along with the actual dimensions. Question number 6. Determine the values of k for which the expression x squared minus kx minus 6 can be factored. Question number 7 is Peter throws a ball into the air from roof of a building. The height of the ball over time can be modeled by the equation h equals to minus 5t squared plus 12t plus 9, where h is the height in meters and t is time in seconds. When does the ball hit the ground? At what time did the ball reach the maximum height? What is the maximum height of the ball? Very common application question. You should definitely know how to answer this. The last question here is tricky. It says determine the values of n for which the expression n squared minus 4n minus 5 results in a prime number. So that is probably a tricky question, but I think others are straightforward knowledge-based questions. Now let's begin with the solution from the very first question, which is we need to find the greatest common factor. You can now pause the video, answer, and then look into my suggestions. So let's write down the answers. For the very first one, it is 9x squared plus 6x plus 24. Well, only numbers we have a common factor. So here we can say the greatest common factor is equal to, we are looking for 9, 6 and 24. It gives us 3. So that is the greatest common factor. The second one, the greatest common factor is x to the power of 5, 4 and 3. X cubed is the greatest common factor. And for the third one, the greatest common factor is nothing in numbers. With x it is x squared, with y it is just y, so that becomes your answer. Perfect. Let's move on to the second question, which is factor fully, use most appropriate method. The first one is x squared minus 8x minus 20. So in this case we will use product and sum, correct? So we are looking for product and sum. So let me rewrite one by one. We have x squared minus 8x minus 20. So we're looking for product and sum. So we say product of two numbers should be minus 20 and the sum of these two numbers should be equal to minus 8. Well, the combination which is going to give you this result is what? Well, 20 you can get as 10 and 2, where the bigger number should be negative, and that is what you have. So you could write this as x minus 10 times x plus 2. So that becomes the factored form for the first one. Perfect. The second one here is minus 2x squared minus 10x minus 8. Now what will you, let me just make a room here. So in this particular case, I think you should take minus 2 common. So we'll group factor. So we'll do minus 2 common and we get x squared plus dividing by 2 you get 5x, dividing by 2 you get plus 4, And now we can do sum and product once again. 4 and 1 can work for you. So x plus 4 times x plus 1 becomes the answer. Correct? Now we have 4x squared minus 1. It is difference of squares. You can clearly see it could be written as 2x plus 1 times 2x minus 1. So that is factored. Let's do the last one, which for us is, well, something is missing here. It should be 28x. So let me write this as 4x squared plus 28x plus 49, right? So plus 49. Now this seems to be a perfect square. So you could write this as 2x whole square, and that is 2 times 2x times 7. So it could be written as 2x plus 7 whole square. So that is the right answer. So we have four answers here. First one A, and then this is for B, this is for C, and that is for D. So I hope you get the same answers. Let's move on and take the next question, which is factor fully, use most appropriate methods. This time we have four terms, 3ax plus 3ay plus 2x plus 2y. Well, let's take 3 and a common from the first two terms. So we are left with x plus y. In the second term, we can take 2 common. We'll get x plus y. And now x plus y is common. And so what we get here is 3a plus 2, and that becomes the solution. The next one here is minus 5x y minus y plus 3z y minus 1. Well, y minus 1 is a common factor, so we'll take this. We'll get minus 5x plus 3z. So that becomes the solution. So we got all these solutions. The answers are underlined. Let's take the next question, which is question number 4. Determine the value of k in 4x squared plus 12x plus k that will create a perfect square trinomial. So let's rewrite this: 4x squared plus 12x plus k. We want a perfect square trinomial. That means something like this: 2x whole square plus 2 times 2x times this term, which will be square root k, and this should be square root k whole square. We need a perfect square. Do you get the idea? So that is kind of important to understand. That is what we are looking for. Now, how could you get that? That really means that 2 times 2 times square root k should be coefficient of x, which is 12, right? That means square root of k should be equal to 12 times 2, which is 4, that is 3. And this implies that k should be equal to 3 squared, or 9. So we have our answer that k is equals to 9. So let me underline this also, highlight it. Perfect. So I hope the concept is clear, right? Now we are getting into the application question part. Question number 5. The area of a rectangle is given by the relation a equals to y square minus 11y plus 28. Provide an algebraic expression for length and width of the rectangle. That means we have to factor it. So we have a here as equal to y square minus 11y plus 28. We can use sum and product to factor. 28 is 7 times 4, so we get y minus 7 times y minus 4. So that becomes length and width. So we have length as equal to y minus, let's say, bigger one, y minus 4, and width as equal to y minus 7. Does make sense to you? Perfect. So these are the expressions for length and width. Part B. If y represented 10 centimeter, determine the area of the rectangle along with the actual dimensions. So we have to give both dimensions also. So it's a good idea to find the dimensions first. So the length will be 10 minus 4, which is 6. Width will be 10 minus 7, which is 3. And area is going to be product of 6 and 3, which is 18. and the units will be centimeters. Let's include centimeters in the answers, and then we underline our answers. So there you go. The area unit will be centimeter square. Be careful. Okay, that is the end of question number 5, and let's begin question number 6, which is determine the values of k for which expression x square minus kx minus 6 can be factored. So when you notice values, you should try to give maximum number of solutions possible. So let's look into this. We have x squared minus kx minus 6. What do we want? We want to factor this, right? Can be factored. So that means we are looking for combination of product and sum, right? So that is what we are looking for. So once we get this combination, we can actually factor it. So let's now figure it out. So let us say we want product of these two numbers as minus 6 and the sum as let's write minus k. That is the sum which we want. So we look for numbers. What numbers can give you minus 6 as the product, and what numbers, when you combine them, will get the k value. Minus 6 could be possible if I do minus 3 times 2, that is minus 6. And when I add them up, that is to say, when I do minus 3 plus 2, what do I get? I get minus 1. So that is the value of minus k. You get the idea. Well, we could also do 3 times minus 2. That will also give us the result, right? So when I do that, then 3 minus 2 is plus 1. 6 you can also get as 6 times 1 with a negative sign. But when you add 6 and minus 1, you get the result 5. And you could also go for minus 6 times 1, and that would be minus 6 plus 1, which is minus 5. So minus k has all these values. Perfect. So you can now write down your answer where the k value could be plus or minus 1 or plus or minus 5. Perfect. So this is kind of tricky. I hope you understand how can we provide all the solutions. That is key. Now let's look into question number 7, which is an application question. Peter throws a ball into the air from the roof of a building. The height of the ball over time can be modeled by the equation h equals to minus 5t square plus 12t plus 9, where h is the height in meters and t is time in seconds. When does the ball hit the ground? So when it hits the ground, at that time height becomes 0. So we need to really factor and figure out at what time the height is 0. So let's do this part. So we have h equals to minus 5 t square plus 12t plus 9. So when you factor, you get, well, let's take a minus outside, and then we'll actually factor this. We're looking for product and sum. Product is minus 5 times 9, which is 45, and the sum is 12. So the numbers which could work for us will be 3 and 15, right? So 3 and 15 can work. So since we have 12 here, we could actually take plus 15 and minus 3. Okay, so we'll just factor this out. So minus 5t squared, and we'll split this into plus 15t minus 3t plus 9. Factoring minus 5t from the first two terms will give us t minus 3. And here we can factor minus 3. We get t minus 3. So now we get t minus 3, and we get minus 5t minus 3. We can take this minus common. So we can write this as t minus 3 times 5t plus 3. Now that gives you two zeros, right? So that gives us two zeros. T minus 3 equals to 0 means t equals to 3. And the other term here is t 5t plus 3 equals to 0, and that gives you t equals to minus 3 by 5. Now that answer is not valid, right? So t has to be greater than or equal to 0, so this is not valid. So this is the right answer, t equals to 3. And therefore, we can now write down our solution that ball hits the ground at t equals to 3 seconds. Does make sense to you? So that is how we are going to answer this question. Now, part B and C, there is less space here. So we'll move on to the next page. So I'll write down the factored form in the next page, and then from there we'll begin. Okay, so let's move on to the next page. Same question. We have h equals to minus 5t squared plus 12t plus 9, which we just factored as t minus 3 times 5t plus 3, correct? That is what we got. So we got minus t minus 3, 5t plus 3, t minus 3, 5t plus 3. Now the question here is, at what time did the ball reach the maximum height? How are you going to figure this out? So let me sketch the situation and then explain you. So what is happening is that the ball goes up from here and then it falls to the ground. Perfect. So somewhere in between, it will reach its maximum height. So let's say somewhere here. Now this value is the mean value of the two x-intercepts. Now here we got the x-intercepts as these 2 points. This point here was minus 3 by 5, and the point there is 3. So the average value is sum of these two, where we are going to get the maximum. Do you see that? So we have to find this value t for the maximum height, and this value t is equal to the average of two, right? Average value. So we'll add them, which is 3 plus minus 3 by 5 and divided by 2. So that gives you 5 times 3 is 15 minus 3 over 5 times 2. That gives you 12 over 10 or 1.2. So 1.2 is the value of time. This is in seconds. And here we have height in meters. Is that clear to you? Perfect. So we got this answer. At what time does the ball reach the maximum height? T is 1.2 seconds, right? So let's move on and write down the answer as 1.2 seconds. Part C is, what is the maximum height? So height is at this particular time. So let's measure, find, calculate this value. So height is equal to, we can use 1.2 in our calculations. Let's use the original equation, which is minus 5, 1.2 square plus 12 times 1.2. You can actually use calculator to figure this out. So minus 5 times 1.2 square is 1.44, plus 12 times 1.2 is 1.44, but decimal 4, plus 9, and that's what you get. So let's multiply, and with minus 5, 5 times 4 is 20, 5 times 4 is 20, that means 2, 5 times 1, which is 7, with a negative sign, and these two combined, we have 23.4. And then you can get the value of height as equal to 23.4 minus 7.2. So we have 0.20, and 23 take away 7 is 16. So we have 16.20 as the solution. And the units will be meters. Perfect. So that becomes the answer. Let me rewrite this answer as, so t equals to 3 seconds and maximum height will be 16.2 meters. Perfect. So that is how we are going to answer this. So I hope it is absolutely clear. So this particular point here is basically 3, 16.2. Let's take the last question here, which is, determine the values of n for which the expression n square minus 4n minus 5 results in a prime number. Now prime numbers have only two factors, keep that in mind, the number itself and 1. So when you factors means when you product and sum will do and find out the factors for the polynomial. So minus 5. N square minus 4n minus 5 can be factored as 5 is 5 times 1. So we can keep minus 5 and plus 1 to get minus 4. So those are the factored form. So what we are looking for? We are looking for the factors of these to be plus or minus 1. So the factors could be plus or minus 1, and the second factor has to be a prime number, right? Like 1, 2, 3, 5, 7, right? Prime number. Okay, so it's easy to calculate with plus and minus 1. So now we are going to do our calculations. We'll say, well, if n minus 5 equals to plus 1, then n is equals to 1 plus 5, which is 6. Now if I substitute 6 here, then n plus 1 will be 6 plus 1, which is 7. That works. So we have n equals to 1 as one of our solutions. Perfect. In that case, the value of the expression is 7. Is that clear to you? Now, that is how we have to go about it. Now, let's also calculate with the value of n minus 5 equals to minus 1. In that case, n will be minus 1, sorry, plus 5 I wrote first. So n will be equal to plus 4. Well, that doesn't work. So that doesn't work for us. So we'll leave this. So that is not a prime number. 4 is not a prime number. So we'll just forget about this one and try with n plus 1 now. So if I write n plus 1 as equal to 1, we get n equals to 1 minus 1, which is 0. If I substitute 0 in the first factor, I get minus 5, which is a prime number. So that again works for us, right? So that again works for us. So n equals to 0 works for us. So we can write down one of our answers as n equals to 0. Now let's look for another solution, which is in this case n plus 1 equals to minus 1. Then n equals to minus 1, which is minus 2. If I substitute minus 2 in the first factor, we get minus 2 minus 5, which is minus 7. That works. And therefore, n equals to minus 2 also works for us. Correct? And so we have three answers in this particular case. So our answers here are n equals to 1, n equals to 0, and n equals to minus 2. These three numbers will result into prime numbers. Do you see that? So if I substitute n equals to 1, I get a prime number, which is 7. And if I substitute n equals to 0, I get a prime number, which is 5. And minus or plus doesn't matter, it's a prime number, and then we get 2. So these are the prime numbers which we get. Perfect. So we have the values of n for which we get the prime numbers as for the expression, correct? So with that, we end the test papers. I hope you find it interesting and useful, especially the last question is very tricky, and I've seen many students not able to attend this particular question. I hope that helps if it comes in your test. So with that, we end. Thanks for your time. If you like and subscribe to my videos, that'd be great. Feel free to post questions. Thank you, and all the best.